You'll have to excuse me. I'm still working on this talk. Yeah. Oh, yeah, it's boomy. Okay. I'm just totally wired. I've been here for 3.5, 4 days. I've got about 8 hours sleep in the whole time, so I best get going because there's too much material here. So here's the introduction. My talk is called Regression Obsession. In the rapid software testing namespace, we think of regression, well, think about it as the opposite of progression, right? It's from regress. It means returning to some prior state, something the way things used to be. Also means getting worse, right? Typically, that's what we mean. I mean, there's a statistical meaning, regression to the mean, then there's also the sense of getting worse, things getting worse. Regression testing for us is testing focused on risk related to regression, regression-related risk, or risk related to change. Obsession. Obsession is the state of being obsessed with something or someone. Like she cared for him with devotion bordering on obsession. Or it's something that consumes our minds. It's something that consumes our thinking. He was in the grip of an obsession that he was powerless to resist. I got that from Google. Usually I go for Oxford or Chambers, but I was in a hurry. We might be powerless to resist, but there's a worse problem. We might be powerless to notice that we're obsessed because of whizzy-addy. Whizzy-addy, what's that? Whizzy-addy is a term made up by a guy named Daniel Kahneman. It stands for what you see is all there is. And it's a book that I recommend that every tester who hasn't read it yet read. And if you've read it, read it again. It's a fantastic book, Thinking Fast and Slow, and it's about systematic errors that we make. By the way, if you want to take pictures of the slides, that's okay. I'm going to make them available after the conference, although it'll take a little while to edit them into a readable mode because there's animations and stuff. Kahneman and his partner Amos Tversky were famous for writing and talking about heuristics and biases. Here's some of the ones that seem to feed obsessions. The endowment effect. We like our automated checks better than anything else because they're ours and we built them. The idea of the sunk cost bias. We spent a lot of money developing this stuff and a lot of time and a lot of effort, and it's better to keep going and not change. That happens when people buy stuff or invest in something and they have to keep it. Survivorship bias. The people writing the automated checks do find some bugs and everybody else got fired. We're all software development engineers in test now, SDETs. And then the self-fulfilling prophecy, which is we checked for these specific problems and we found some of them. And although we're not really keeping track of what problems happen in the field, we're not keeping track of what got away, and we're not thinking about them, we're not evaluating them, and they're probably just bad luck. Why are we obsessed with regression testing? There's a few reasons, I think. One is that regressions, when the product slides backwards in quality, it's embarrassing. It suggests that the programmers are being careless or even reckless. Regressions, when managers or developers see regressions, they think, well, come on, testers, why did you miss that? I mean, once you've seen it working, it should be really easy to see it not working, right? Automated regression checking allows testers to write their own code. Testers get to be coders, and therefore testers get to feel just like developers, and developers are really valued. That's the serious part of the introduction. And now it's time for you to meet some of the voices in my head. I had this idea that I would bring somebody up and we would talk this stuff over spontaneously. And I could do it, but I would worry about looking like a not nice person when I challenge some of the things they said. So I'm going to make up somebody who is talking to me, and well, a bunch of people maybe, and then there's me. I'm the guy. If you look at this screen, I'm the guy over here. Okay. So my problem is I don't know where to start. See, because there's so much stuff. For instance, I noticed this thing the other day. This guy wrote email to me and James congratulating us for being his number 1 and number 2 choices on automation testing blogs. See? Just like that. There it is. Automation testing blogs, me and James. And then this other guy posted this thing. We're going to do a meetup next week. James and I are. And look, automation luminaries, Michael Bolton and James Bach. Automation luminaries. As though testing and automation were the same thing. As though there were nothing more to testing than automation. I'm turning into this grumpy old man about this thing. Is testing nothing more than automation? Is that what's going on here? Have we even forgot? I mean, we're automation. They doesn't even mention testing in the thing he's talking about it. And I'm turning into this grumpy old man. And then another voice says in my head, calm down. But talk about regression testing. Just talk about regression testing. Everything will be okay. Why did you call your talk Regression Obsession? I did that because I believe people are fixated on tools, and they're fixated on regression checking. I'm worried that shallow checking is displacing, it's being confused with, and it's getting in the way of deep testing. We got these wonderful tools that help us to build really quickly and really fast, and yet people think, oh, well, because we got a whole bunch of automated checks on that, then everything's going to be okay quality-wise. I'm concerned about that, and I think serious testers should be concerned about it too. What's unique about us, serious testers? The idea is that we test more deeply and more reliably. That's what we aspire to do. That's what we want to do. Okay, see, there's the C. And we got these happy CI and CD fans who are saying that testing is easy. And we say testing is hard. Now, there's a frowny face there, but actually it should kind of be a happy face too. Because testing, I like testing for hard things. Now, of course, shallow testing is easy, right? If the treasure is right there near the surface, testing is easy. But if the testing is way down deep, if the treasure, the bugs are deep or hidden or subtle, there's all these sharks surrounding it, and you got to put on a pressure suit, and you got to go down, and you need skill, and you need experience, and you need practice in order to survive in those kinds of environments. Why do we test more deeply and reliably? Because we want to. We like doing it, and we like learning how to do it, because that allows us to learn about all kinds of stuff. It allows us to learn about technologies and psychology and how people can fool themselves. Testing is deep to the degree that it has a good chance of finding problems that actually matter, and that those problems are deep or rare or hidden or subtle. And it requires skill. It requires work. It requires preparation. It requires help from other people. It requires tools. But the point of it is that it reliably and comprehensively fills the mission of testing. By contrast, shallow testing doesn't do that. So how do you get deep? 10 things. It takes time. It takes determination. You have to want to do it. It takes skill. You need to practice your skills, and you need to know how to model the product. You need to know how to investigate the product and design experiments to evaluate it. You need learning. You need to develop rich and detailed models of the product. You need lots and lots of different test activities. You may need sophisticated tools in order to do deep testing. You may need a variety of environments for testing. Usually you need enough environments to represent what things are going to look like in the real world. You need data, rich, challenging data. You need support from the team. And you need testability. You may need special features built into the program, and you may need a project environment that allows you to test deeply. And then one of the voices in my head says, but we don't have time for deep testing. That literally means we don't have time to look for hidden or rare or deep or subtle or intermittent problems and potentially destructive bugs. Are you okay with that? If something, now it's okay. A lot of places are, a lot of products these days don't matter very much. If there's an ad missing on Facebook, no customer cares, no end user of Facebook cares, but Facebook's real customers, the advertisers, might care very deeply. If something is missing from your social media feed, you probably won't notice it because there's so much crap going by. So why test? Why test at all? To show that the product works. Right? 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 No! That's a terrible idea to show that the product works. Terrible idea. We test to avoid fooling ourselves. We test to avoid fooling ourselves. We test to learn whether the product we've got is actually the product we want. And for management, that's especially important because we test to learn about problems that threaten the value of the product or the on-time successful completion of the project, whatever that project is. The current sprint, the current release, a change to this line of code, the long-term sustainability of business. We test to learn about problems that threaten those things. We test to investigate the product with a focus on finding problems that lead to business risk. That's why we test. And yet, testing is socially awkward. It's hard to be a tester because testing is disruptive. It leads to controversy. People get upset when we find problems. We find them and we report on them, and nobody likes that. Nobody likes to know about problems. I mean, they sort of want to know about problems because they want to look good in the end, but meanwhile, it's a pain in the butt because problems create work for somebody, and sometimes for lots of people. We have to decide whether it's a problem worth fixing, and if we do, we have to fix it. Well, I love the we. Testers don't have to do that. The programmers and the designers and the managers have to do all that stuff. And so, there's a solution that I see going around. Wouldn't it be easy just for everybody to be a programmer? That's what the Agile people suggested. All we testers can be programmers too. Wouldn't that be great? We'd be writing code, and so we'd look good. We'd find some bugs, although not too many, because, you know, when you're writing code, isn't the problem that we already had enough code that wasn't working that great in the first place, and now we've got testers writing code, and testers aren't professional programmers in a lot of cases, and that means that the code that testers write isn't going to be as good as the code the programmers write, but it's got to be better than the code the programmers write if it's going to find the bugs. If we did it this way, then the bugs we found would not be terribly controversial because they'd be focused on functional problems in the code. And it wouldn't be focused on all that human, squishy, they call it non-functional, parafunctional, value-related things, you know, the things that actually bug people. Fixing those problems would be fairly easy too because they're basic functional problems in the code. No worries. So here's how we achieve harmony in the world. We join with the dominant culture, the culture of programming. We automate the testing. We master the machinery. We prevent regressions. We do testing faster than those manual testers ever did. Wait a second. Well, the scare quotes. So my voice, my grumpy old man voice asks, what is regression testing to you guys anyway? To all the other voices in my head. And the other voices in my head representing some of the testers out there in the world say, oh, it's any test that we performed before. But a test that we performed before might not find a new problem. Just because we've done the test before doesn't mean it's going to find a problem that's come in. Testing to make sure that nothing is broken. Well, you can't make sure that nothing is broken. Testing that we perform after some change. Oh, well, okay, that's maybe not too bad an idea. Testing to probe whether quality's got worse. That I kind of like. That's pretty good. Running automated tests on every build. Okay, let me pick on that last guy. I don't like that last guy. There's no such thing as an automated test. Got that? I said this to somebody last night at the reception last night. I said, there's no such thing as an automated test. And you had, what? Huh? There's no such thing as an automated test. Testing can't be automated. Testing can't be automated. Oh, thank you. Come on. Testify. Can I get an amen? Testing cannot be automated. Why not? Let's call this checking. Checking is operating a product algorithmically to check specific facts about it. Think spell checker. Think compiler checker. But we don't call a compiler an automated programmer. We don't call it automated programming just because we got compilers and compilers check. To check means to operate and observe the product algorithmically in specific ways to collect specific observations, and then to apply algorithmic decision rules to those observations, and then to report algorithmically on the outcome of those decision rules. Algorithmically. Is there a key word that you notice here? Algorithmically, algorithmically, algorithmically. If a check can be performed algorithmically, it can be performed by two agencies. One is a machine that can't think, but which has the virtue of being very fast, very precise. Or by a human who is sufficiently disengaged, because humans don't naturally behave algorithmically. People find it hard to behave algorithmically. And they're slow and they're variable, except quick and slow refers to the speed of observable behaviors, not actions with intentions. The machine is infinitely slow at recognizing trouble that it hasn't been programmed to recognize. And that's a big problem, because lots of things about a product that would annoy us are not algorithmically evaluatable. It requires people. It requires a complex social judgment in order to decide whether this problem that we're seeing in the product is something that humans will live with, will tolerate, will repair, or which they'll find horrifying or terrible. So testing is so much more than checking. It includes checking. Checking's a part of testing. Checking is something that we can apply during testing. But testing is evaluating a product by learning about it through exploration and experimentation. It's an open-ended process, not an algorithmic one. And that includes questioning the product, studying the product. It includes modeling the product, observing it, making inferences about it, generating ideas, and elaborating on ideas, and refining ideas, and overproducing ideas, and recovering ideas that we've abandoned. It includes collaborating with other people. It includes recording and reporting. It includes navigating and map making. It includes risk analysis. It includes looking for problems in an open-ended search. But of course, testing is more than that. Testing is creating the conditions necessary for doing all those things, so that our clients can make informed decisions about risk. And it also involves developing yourself as a tester. It involves developing yourself as a tester. It involves developing the inclination, the skill, the motivation, the drive, the competence, and the reputation and the credibility for doing all those things. Whoops, hang on. I gotta do this thing here. Let's see. Whoops. God, PowerPoint. There we go. See that stuff? All that stuff, acquiring skill stuff, that can't be automated. It can't be automated. So maybe some of you have seen this on the interwebs. I'm going to do it now because I'm wired. Here we go. You like rap music? I got to do this real fast today. experimentation learning, freestyle exploration, studying and modeling, conjecture observation, test code development, task prioritization, checking out competitors, preparing simulations, formalized reporting to comply with regulations, gathering, assessing, and applying information, deliberation, judgment, designing visualizations, setting up the lab to try complex configurations, working out the problems in a puzzling situation, finding ambiguity in a product specification, trying to look beyond the predicted expectation. That's because testing's all about investigation, questioning and learning, playful product interaction, trying to keep my focus while I'm managing distraction, sense-making, myth-breaking, decision-making, no faking, stressing out the product to discover where it's breaking, interrupted and disrupted because the product's full of bugs. The fellas who developed it must have been on drugs, refining test approaches through deliberate practice. How could hackers hack this? Don't give them access. Wrestling with the problems in the setup of environments, interviewing users who discover their requirements, so I shall socialize to promote collaboration. Other folks can help me with my testing preparation, talking with the managers to learn what they require, testing for charisma, that's what customers desire, working with the app marketers to show the app's power, point to all the figures, try to feature in an hour, selecting, configuring, and then applying tools, remembering critical thinking, confirmation is for fools, refactoring at every step, keeping things maintainable. Let's get over overtime and keep the pace sustainable, building coverage models, analyzing risk, eliminating waste, trying to keep the pace brisk, pattern recognition, distributed cognition, helping shy colleagues get over inhibition. I want to say this while I'm in a rap rhythm. A check's a part of testing encoded in algorithm. Testing's much more than automated checks and test cases. Human variation puts the product through its paces. Talk of manual testing will keep our craft stuck, but testers keep referring to it. I say, what the? Use the tools powerfully. That's what I'm suggesting, but don't try to tell me you can automate the testing. Wired, I say I am. Wired today. Wired. Here's why it's important to distinguish between testing and checking. Checking is mechanistic. It can be made completely explicit and automated. It's inside testing. It's a tactic of testing. Look, it's like the difference between biting and eating. Nobody confuses biting and eating, right? That's biting. That's eating. You can even automate the biting. You can automate the biting with a Cuisinart, or you can automate biting that way and just do silly biting. Nobody confuses biting and eating. Your mother never says to you, you won't grow if you don't bite. Right? I haven't had breakfast this morning. By lunch, I'm going to have to bite something, right? Biting can be done by tools, but eating can't. Eating is a social thing. Testing is a social thing. It's not just the mechanical comparison of outputs to predicted results. Now, checking is okay, but it's mostly focused on confirmation, verifying things that we know to be true or hope to be true. And to escape problems with that, our testing has to do more than checking, much more than checking. Because computers can do things very fast, but they're kind of slow. And then the voice in my head says, wait, isn't confirming that the product works a good idea? Well, we can't confirm that the product works. We can't confirm that the product will work. We can't confirm that the product does work. All we can confirm is that we saw the product work. We can't confirm that it will work. That's an inference based on us seeing the product working one or more times. But it doesn't matter how many times we've run the product before. That's not going to tell us about the future. Strong inferences or weaker inferences, but it can't tell us what's happening. What it means when we say it works is what it appeared to meet some requirement to some degree. Some aspect of some feature appeared to meet some requirement to some degree based on some theory and based on some observation that some agent made under some conditions once or more. It works on my machine. Now I'm going to get all academic. I'm going to do something really bad. I'm going to read a slide. Most of the technology of confirmatory non-qualitative research in both social and natural sciences is aimed at preventing discovery. When confirmatory research, like automated checking, goes smoothly, everything comes out precisely as expected. Received theory is supported by one more example of its usefulness and requires no change. We thought the product worked. Look, here's a check that confirms that it works. As in everyday social life, confirmation is exactly the absence of insight. In science, as in life, dramatic new discoveries must almost by definition be accidental or serendipitous. Indeed, they occur only in consequence of some mistake. That's from a book called Reliability and Validity in Qualitative Research. Isn't it amazing it's not flying off the shelves at the airport with a title like that? And I recommend that testers read this book, and I recommend that testers study qualitative research, because that's what testing is too, qualitative research about a product. If we repeat stuff over and over again, confirm that there are no bumps in the happy path, that actually helps us to avoid the discovery of problems. But if you want to find the things that customers are going to trip over, you better explore and map out the product and continuously not integrate it so much. You continuously integrate it, sure, go ahead. But you've got to continuously go deeper on the product if you're going to find the deeper, rare, hidden, or subtle problems. Induce variation. We can use tools really powerfully to help with that. But I don't hear very much about tools that allow us to map out dependencies in the product when the developers say, oh, you have no idea how the product's going to change. I don't see people doing that. I don't see people profiling the product, doing little benchmarking checks for each little unit of the product to find out when all of a sudden a routine is taking longer than it used to. You know, people want to count bugs. They want to track defect escape ratios. I got an idea that I'd prefer we all do, which is to learn from every bug. Not reduce engineering to scorekeeping, but learn from every bug. So the voice in my head then says, are you saying that all checking is useless? No, checking isn't useless, but we should really think about how to do it well. For instance, one way of doing it well, I'm kind of interested in this. Low-level checks are fine. Unit-level checks are great for programmers to get fast feedback. And I think contract tests, contract checks really, but where we get a whole bunch of things from customers saying, you know, we would like you to check this out, and applying those to the prospect of regression, that's a pretty cool idea. I'm kind of cool with that. But let's be aware of problems with checking at the user interface. Sure, I'll show you a funny video about it. No conference talk is complete without a funny video. Here's how this goes. Notice what's happening here. Okay, she's holding it up. The kids are holding this up to the light switch, holding a machine and pressing its button so that it can press a button that was made for a human to press without a machine. Right? That's what's happening down at the bottom. That be like Selenium, that be. It's GUI automation at its finest, using a machine to exercise a human interface in a way that a human would never do it. The problem is that too often, checking turns into GEMPOB. I don't know, it almost kind of looks Russian, doesn't it? It looks almost Cyrillic. Here's GEMPOB in a bunch of different fonts, just so you see it again, a bunch of different ways. There you go. What does it mean? It means getting machines to press their own buttons. Getting machines to press their own buttons. That's what checking descends into a lot of the time. Automated GUI checking, getting machines to press their own buttons. Now, why are people fixated on this? One, sunk cost. Testing is misunderstood as being about confirmation, checking. There's a big test space to cover. The space is currently being covered by shallow manual test cases, human checking. Those checks took a long time to develop and write, so we're not going to throw them away. And since they're already a lot like algorithms, we can encode them and get the machine to do those. Which is an application of the old rule, when something isn't worth doing, write code to do it faster. Number two, well, do something. So the first two premises are the same. And then people want something done to prevent embarrassment, like a missing screen or a missing button someplace. So they'll often settle for showing that something exists and that it can work. And then getting a tool to visit every screen is where something, perhaps, or at least the screen is there. And as long as we do that, we can say that deeper, rare, hidden, or subtle bugs they're just bad luck too. They're too hard to find. The machine couldn't find. Not even the machine could find them. And this happens. I worked at a bank one time, well, it's a banking-like institution, where they had a product that had 1,500 screens with lots and lots of different options on each one. You didn't want one not to be there. Of course, nobody checked, nobody bothered to look and see if the product was actually useful or reasonably designed. So when you can't figure out what to do something, right? Idea number 3, same 2 premises, and then programmers are under lots of pressure to produce features. Unit and integration tests take time to produce, and that takes time away from developing features, so we get the testers to do it. Low-level and mid-level testability isn't a programmer priority either, because the business says, build more features. And then developers are really busy because they're busy fixing bugs, and then there's a loop. You go back to 3. Therefore, get the testers to write checks at the browser level, where the testers can kind of comprehend what's going on and see it. And a voice in my head says, well, that's why we need regression testing. With the developers under pressure, stuff is breaking all the time. That's an example of an organization not listening to the squeak in the wheel, not smelling the fire. Regression checking won't solve that problem. See, the fantasy is I rerun my old tests to ensure that nothing is broken. There's a product, and it's got all these little bugs in it, and the mothership comes down, and our regression checks pick up the bugs, and they suck them away, and they take them away, and then, well, there's a problem, you see. This can only be true if your old tests cover everything perfectly, with perfect oracles. An oracle is a means by which we recognize a problem when it occurs during testing, when we encounter it, so that all conceivable bugs have been found and fixed and checked. The reality is more like this. We run some old checks to make sure that they don't find bugs, and we also assume that any bug that the checks don't find is unimportant. We have to automate. Our programmers are working so fast they don't know what might happen. Anything could happen. If that's true, the product is out of control, and the project is out of control. It's like a building with no sprinklers, flammable materials, and then there's probably some arsonists running around setting fire to stuff. When you're doing that, you don't add more smoke alarms. What you do is you learn about the problems in the building and you get those fixed. As testers, we don't fix them, but the least we can do is to learn about the product and to take our learning to the people who can fix it and make them aware of the risk of not fixing it. If you're seeing a consistent pattern of regression, it's problems, but treat those problems as symptoms. The failing checks or tests probably aren't your biggest problem. The biggest problem is probably you've got an environment, a situation, a project where regression is likely to happen. And that's a severity 1 project risk. But regression checking gives us more time for exploratory testing. Nope. Because regression checking, if it's going to be any good, has to come from exploratory work. We have to learn how to check the product well. And that's not something you can schedule. That's not something that you can put into a nice scripted little box. In order to learn, we have to engage in open-ended activity. We have to have conversations. We have to interact with the people in the team to identify possible sources of risk. Now, if you say, well, but it's inexpensive to run automated checks. Well, yeah, it's inexpensive. But what about the other costs? Have you considered design time, coding time, debugging time, maintenance time? The cost of passing what we know about the checks on to other people. I see people, I go into organizations, they say, oh, we have 40,000 automated checks that we run on every build. What that means is there's 40,000 things that people don't know about, probably. They haven't looked at them for a long time. Equipment costs, setup and configuration time, interpretation time when a check runs red. What's going on? Is there a problem in the check or a problem in the product? Opportunity cost. Displacement of other things that might be valuable, right? If we're spending time developing and debugging and maintaining automated checks, that takes away time that we could spend investigating the product. I had a conversation with a guy last night who was telling me about spending a week trying to fix a bug in his checking. A week. You know what? Here's a suggestion on that. Whenever you run into any kind of trouble, whenever you feel stuck, apply the 10-minute heuristic. If you're stuck for 10 minutes, go ask somebody for help. Take a break, go have a shower, stop working on that problem. Let your brilliant, wet human computer process stuff in the background and let it join with other wet human computers. And you'll come to an answer. Have you ever observed and evaluated these costs? Everybody's so fascinated. Managers are so fascinated by things flashing by on the screen. But have they ever thought what it took to get there? Stuff is changing all the time in our product. Are the checks keeping up with that? And one of the voices in my head says, well, we think so. Most of them are still running green. Well, okay, I presume you fix the red checks that aren't really bugs. But what about all those green checks that might actually be bugs? What about all the checks you've never run? Humans can recognize those things. Humans can get new ideas. Humans can recognize problems that are going to matter to something other than a machine. There's a line from Jerry Weinberg's book. I have to mention the passing of Jerry Weinberg. It's a very sad thing to have lost Jerry. He died in August of this year. A towering figure, and I recommend really strongly that you read his book, Perfect Software and Other Illusions About Testing. All right. We've got 5 minutes. Good luck with that. We've got to replace obsession with strategy. What's a test strategy? A test strategy is a set of ideas that guide your choice of tests. That doesn't mean a document. It doesn't mean a thing on a whiteboard. It means a set of ideas in your head that might be shared with other people. It might be very formal. It might be informal. It's not. It may be documented, but it's always documented partially. To guide your choice of test. To guide is to influence, but not necessarily to determine. Testing is shaped by lots of factors, in addition to strategy, the environment we're working in, skills, opportunities, mistakes, opportunities we get from mistakes, the power of tools and the limitations of tools, testability, biases. The guide your choice of test. By that I don't mean the guide your choice of test cases. Testing isn't about test cases anyway. What tests to design, how to design them, the decisions made during test design. And in order to do that, we need to have models of the project and models of testing. We need to think about the project's mission, the testing project's mission, the information we got available to us, a relationship with the developers, the test team, equipment and tools, schedule, test item, deliverables. We need to think about the product's elements, structure, function, data, interfaces, platform operations, and time. Usually, automated checking only refers to the functions in the product. Very weak variation in terms of data and operations. We need to think about things that matter to people. Not just capability, but also reliability, usability, security, scalability, charisma, performance, compatibility, installability, configurability, and then things that matter to us internally, like supportability, testability, maintainability, portability, and localizability. We need to think about test techniques like function testing, stress testing, domain testing, flow testing, scenario testing, claims testing, user testing, risk-based testing, and automated checking. Automated checking is all right, but look at all these other approaches that can be blended into our automated checking, and we need to think about how we recognize problems, patterns of familiar problems, inconsistency with explainability, inconsistency with the world, inconsistency with history, inconsistency with the image we want to project, with claims, with comparable products, with user desires, with product, with purpose, with standards and statutes. We need models at testing like this in order to do a good job of testing and not just of checking. So people are telling me that my time is up. And let's see if there's anything that I feel really urgently I have to tell you about. Yeah. Oh, I'm actually really close to the end. Instead of test automation pyramids, let's think about the surface of the product. And that's how the users encounter it. And then let's think about all the things down below. Quality below is what makes quality above possible. and it reduces dependency on expensive higher-level testing. But we've got to think about engaging the product as people do, looking at the product in terms of what matters for people. How do we determine a weak regression test strategy? Well, we're focused on testing everything on every build. We're not focused on risk. We're not focused on variation. We're focused on repetition. And we're focused on not reviewing our strategies. So here's a handful of things that we could think about. If we want to focus regression testing, think about what we've changed recently. What's really important, what's common or critical, where there's risk or where there's vulnerability or weakness, where variations in the platform can make big differences, where we've made recent repairs, where we've seen problems before. Search online for Karen Johnson's RC, RC, RC. And then there's my two RCs, defocusing heuristic, randomized testing. In other words, vary your test data, vary your sequences, vary your paths. Look at stuff that is confusing, that is known to be complex. Look at stuff that is rich. Look at ideas that are based on stories in the way people actually use the product. And look for things that are compelling, things that would cause loss or harm or damage to people. So here we are, conclusions. Thank you for the 2 minutes. Test strategically, not compulsively. Apply tools that way too. And avoid applying tools to human interfaces. Get humans to look at those things, because we can perceive problems that machines can't. At the conference, watch and listen for these words. This is the keynote part, right, where I send you off with a benediction. If you're not hearing these words in the presentations, challenge the speakers. These are things that we need to talk about as testers. We don't need to hear the word automation, 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 automation. Automation in service of what? In service of finding bugs, in terms of covering the product, in exposing surprises, in avoiding being fooled, in applying critical thinking, and in having empathy for and compassion for and concern for customers, clients, society, people who matter. That's more, far more, than just checking to make sure that the gears fit together. Thank you very much. Automation be like. Any questions? Thank you. Thank you very much.